Present value is a pretty minor topic for AP. You probably wouldn't be asked to do any calculation beyond maybe the most simplest one imaginable. You're certainly not going to have to calculate a bond price, although as we'll see it's really not difficult if you're given all the information that you need. But you do need to understand the relationship between interest rates and bond prices, so we might as well go into a little detail and see what's going on here. And present value is just a good thing to know about in general. A lot of people are making what's really present value decisions without doing the calculations, because everyone understands there's a time value of money and it's better to receive money now rather than later, other things being equal, and that's all the present value is. So we're just looking at it a little bit more carefully. So let's start with just a simple example of earning interest. So I'm going to put $1 in the bank or in some asset that earns an interest rate. Let's just say it's 10%, so I'm just using it in decimal form, and I'm just going to get paid at the end of the year 10% interest. So I have that dollar, then I'm going to add the interest on the dollar, so $1 times 10% gives me the $1.10 right at the end of the year, obviously. So I'm just going to rewrite that as 1 times this factor of 1 plus the interest rate, which gives me this, and that gives me my $1.10, which is the future value in this case. So what I'm calling present value is just the dollar amount in current terms at the current time, and in this case I'm going to turn it into future value by adding that interest payment to it. So when we do a present value calculation, I'm really just turning this around and getting the present value of some future payment. So I just rewrote what we had already, and now I want to know, if I get $1 a year from now, what is that equivalent to today? In other words, what's the present value? So now the dollar that I'm given here is the future value, and I want to know the present value of it. So if I just rearrange this, solve for present value, I get this. So I'm taking that future value and I'm discounting it back to the present. And so we're just doing the reverse of what we just did there. So if I divide by 1 plus r, I get the present value. So having $1 a year from now, assuming that I can earn that interest rate of 10% using this market interest rate of 10%, then that's equivalent to having about 91 cents today. Because if I had 91 cents and I earned 10% on it, I'd get approximately $1 at the end of the year. So just doing the time adjustment, those things are equal given that particular interest rate. So we're just discounting this future value to get the equivalent present value. So we had this is just a copy of what we just have, and now if we change the interest rate, so if I had an interest rate of 20%, then I'm discounting the future payment more. So instead of giving me 91 cents, it's now 87 cents, because the higher that interest rate is, the more costly it is to wait to receive that amount in the future. So the lower the present value is. So if I'm going to get $1 in a year, but I could have earned 20% over that time, then waiting that year gives me a lower present value for the same amount. So that's why we get this relationship between interest rates and present value of any future amount. So this is really the key takeaway, especially in terms of AP, of present value. So when interest rates go up, you are discounting the future more, and so the present value of some amount that you're receiving in the future is now lower, and vice versa. And so that really already tells us what the relationship between any kind of asset value in the future, such as a bond payment, is going to be worth, and so that gives us that relationship between interest rates and that asset price. So now instead of 1 year, let's just do it in 2 years. So I'm going to get that dollar. That's going to be my future value of $1 that I'm going to have 2 years from now. So I want to know what's the equivalent of having that today. What's the present value? So if I were taking some number, just do the original calculation, going from present to future, well, I take some amount, put it in the bank, earn interest on it. That's how much I have in 1 year. And then I'm just going to do it again, earn more interest on that, on whatever I have at the end of year 1, and then I would get that amount in year 2. So just to get the present value of some future amount, whatever that amount is in year 2, I'm going to discount it by this factor. So just 1 plus r squared, that gives me the sum value in year 2 discounted to today. So the present value of that future amount. And so if I did the 10% over 2 years, that would be the equivalent of having 83 cents today, because that's what I would have if I took that 83 cents and let it compound over 2 years, getting interest once a year at 10%. And so again, we have, if I discount at a higher interest rate, then the present value of that future payment is even lower, because think of it as having money today is even more valuable, so that if I have to wait, then it's even less valuable in the future, because I could have been earning that 20% over that 2 years that I'm now waiting to receive that dollar, so it's worth even less to me when I put it in today's terms. So the equivalent of having a dollar in 2 years with an interest rate of 20% is now 69 cents. So interest rate goes up, present value goes down. I'm discounting the future at a higher rate, so it's worth less. So let's look at an example. There's some project that I'm thinking about investing in or doing. It's going to cost me $1,000 today, and let's just assume that I know what the payout is going to be. It's going to give me $400 a year for 3 years, starting at the end of this year, so starting in 1 year. And I'm going to calculate the net present value of this project, which just means I'm going to look at all the costs and benefits, but I'm going to adjust for the time period. Because if I didn't adjust, I would say, okay, it's going to cost me $1,000, it's going to return $1,200. So if I just add up these payments, but not adjusting for the time value of money, you realize something's wrong with that. I would need some more information about what it's going to be worth for me to wait for those future payments. So that's what we're doing in present value. I'm going to have to discount those future payments. So the $1,000 is today's cost, so I don't have to adjust that. That's in present value terms. But then my $400 payment, I have to discount it. So I'm getting that one in a year, I'm getting that one in 2 years, I'm getting that one in 3 years. Right? So that's the calculation we're doing. And if we do that, let's start out assuming the interest rate is 5%, and you did that calculation, you would get a net present value of $89. Now, what does that number mean? So to answer that, let's first look at what we might compare this project to. Now this might be comparing it to lots of things, but sort of the benchmark that we want to look at is, well, I could just take that $1,000 and I could earn whatever the market interest rate is. Some interest rate that I could earn, whether it's a bank or some asset that I can buy and just earn a return on. But I could just be earning a return on that $1,000. So let's think about what that would look like in present value terms, net present value terms. Well, I'm putting away that $1,000, that's my cost in year 0 in present value terms. And then I'm just going to sit there and accumulate interest. So after a year, I would have 1,000 times 1 plus r, and then after 2 years, 1 plus r squared. So after 3 years, this is what I have, my $1,000 plus all the accumulated interest. That's what this value is. But that's in year 3, so I have to discount it by my factor here. That cancels, and we get 0. So what it means to have a net present value of 0 is not that there's no return because I earned interest on this. It means that I've earned this interest rate R. So whatever my discount rate that I'm using, this market interest rate, if I just earn that interest rate, that's what a net present value of 0 would mean if I include, that initial cost here, and that just cancels out and leaving me with 0. That's what a net present value of 0 means. So that's kind of the benchmark that I'm using when I think about what these numbers mean. So the fact that this is positive at 5%, what that's telling me is that this project is doing better than 5%. My alternative is the market earning that 5% interest. Well, this does better than that. So that's what the fact that this is positive, that's what that's telling me. Now, as we know, if I raise the interest rate, I'm going to discount these future payments more, which means the net present value of this project falls. And so if I discount at 10%, this net present value becomes negative, and so what that's telling me is that I'm doing worse than 10%. So it'd be better for me if I can go earn 10%. It's better for me to just go earn 10% because this project is worse than that, having a negative net present value.